Hello and welcome to the session on time, speed and distance. This is brought to you by Handa Ka Funda. The most basic equation in case of time, speed and distance is speed is distance upon time. If the distance is a constant value, that would mean that speed is inversely proportional to time. However, if time is constant, that would mean that distance and speed are directly proportional to each other. The other case would be when the speed is constant, and in that particular case, distance will be directly proportional to the time taken. Let us take an example on this proportionality funda. Suppose a person fires 2 bullets at a gap of 12 minutes. His friend B hears them at a gap of 11 and a half minutes. Then what is the ratio of the speed of sound to the speed of B? What I am trying to say is, suppose here A fires 2 bullets at t equal to 0 and at t equal to 12 at point P. His friend who is standing at Q hears the first bullet at a particular time, let's say t dash. He hears the second bullet at t dash plus 11 and a half minutes. Now why will that happen? That will happen because B would have moved to a different point and he would have come closer, and that is the reason why he will hear the second bullet at t equal to t dash plus 11.5. The question is, what is the ratio of speed of sound to the speed of bullet? Can you find that out? Let's see how we do this. Think about the distance RQ. The man has moved from Q to R in the time of 11 and a half minutes. So B takes 11.5 minutes to cover QR. If the man B was standing at his original position, he would have heard the second bullet at t equal to t dash plus 12. The bullets are fired at a gap of 12 minutes. He would have heard them at a gap of 12 minutes. But that did not happen. Why did it not happen? Because he moved. So that means the sound of the bullet, which is going from P to Q, it passes R at t equal to t dash plus 11.5 and it passes Q at t dash plus 12, which means the speed of the sound, or rather just the sound, takes from here to here. It goes from R to Q in this time gap, which is 0.5 minutes, and the distance covered is RQ. As you can see, RQ is equal to QR. The distance is constant. So the ratio of the speeds which we want to find out will be inverse of the ratios of the times taken. B takes 11 and a half minutes, sound takes 0.5 minutes. So the required ratio is 11.5 by 0.5 or 23:1. Average speed is defined as total distance covered by the total time taken. Let us say a person goes from P to Q with the speed of A and he comes back with the speed of B. What will be his average speed? Will it be A plus B by 2? No. It will be 2AB by A plus B. Think about it. Why? Total distance covered will be in going and coming back. You can say it is 2D. Time taken to go with the speed A is B by A, and the time taken to come back is B by B. If you calculate it, it will come out as 2AB by A plus B. So if a person goes with the speed of S1, comes back with S2, goes again with S3, comes back with S4, and the process goes on till Sn. That is, if the same distance is covered at various different speeds, then the average speed is not the arithmetic mean or S1 plus S2 till Sn by n, but otherwise it is the harmonic mean of the values which are given. That is n by 1 by S1 plus 1 by S2 plus 1 by S3 till 1 by Sn. It's a very common mistake that people tend to make. So once again, average speed, if you go by A and come back by B, is not A plus B by 2, it is 2AB by A plus B. Let us talk about relative speed. Say, two people start from P and Q at the same time with speeds of 15 and 10. The distance between P and Q is 100 meters. Then the time taken by them to meet will be 100 by 15 plus 10. The point that I am trying to make, to cover a distance D with two speeds A and B towards each other, the speeds get added up or it becomes D by A plus B. But it is also important to understand why it happens. Think about it. The distance initially is 100 meters. 1 second later, what will be the case? The first person would have moved to P dash, or he would have covered 15 meters. The second person would have moved to a point Q dash, and he would have covered 10 meters. So the new distance between the two bodies, which was initially PQ or 100 meters, would have come down to P dash Q dash, that is 100 minus 15 minus 10 or 75 meters, which means the distance between the two bodies is reducing at the rate of 25 meters in 1 second. So it will reduce by 100 meters in 100 by 25 or 4 seconds. Let us look at the converse case, that is when the bodies are moving in the same direction. If you just want to find out the answer, what you need to do is directly the distance by the difference of the two speeds, which in this case is 20 seconds. Or the formula, if the distance is d, the person who is behind is moving with speed a, the person who is ahead is moving with speed b, then it is given by d by a minus b. Important point to note, for the person behind to catch the person ahead, a should be greater than b. I know it's obvious, but people do make a mistake in it. Once again, why does this happen? The first person would have moved to a point P dash, which is 15 meters ahead of the original. The second person would have moved to a point Q dash, which is 10 meters ahead of the original. What is the new distance between them? To find that out, please realize PQ was 100, PP dash 15 has gone from it, so P dash Q is 100 minus 15 or 85. However, for P dash Q dash, it will be P dash Q, that is 85, plus Q dash Q, that is 10, or it would become 95. Which means the distance between the two bodies, which was 100 meters initially, has now come down to 95 meters, or it has reduced by 5 meters in a time gap of 1 second. You want to reduce it by 100 meters. If it reduces 5 meters in 1 second, how much time will it take to reduce 100 meters? That would be simply 100 by 5 or 20 seconds. Let us look at a couple of special cases. Suppose there are two bodies which start from P and Q with speeds S1 and S2 at the same time. They maintain constant speeds throughout their journey. The first body is going from P to Q, the other body is going from Q to P. They meet at some point R in between, and after meeting, S1 takes T1 time to complete its journey and S2 takes T2 time to complete its journey. Please note, these timings T1 and T2 are for S1 and S2 and they are after the meeting timings. In that case, S1 by S2 will be given by root of T2 by T1. The same formula is applicable in its exactly converse case, which is this one. Let's see what's happening here. Here, two bodies are starting from P and S1 and S2, but they start at different times. What is given to us is that they end at the same time. They are moving with constant speeds throughout their journey. Also, since they start at different times, when they meet, they would have covered different distances and they would have moved for different timings. So, the first body takes T1 time to reach the meeting point, the second body takes T2 time to reach the meeting point. Then, after they meet, suppose they meet at 3 o'clock and the journey finishes at 5 o'clock for both of them. So, both of them are taking 2 hours to finish it. So, that would be the same. In that particular case also, we can directly use the formula S1 by S2 is root of T2 by T1. Please stay with us to continue the discussion on time, speed and distance. Thank you.